So we'll solve a few problems. We will start from the basic problems. Okay. So find the Z parameters. Here you have a circuit. So here you have one terminal here, other set of terminals here. Okay. So we will take this terminal as input port and this other side as the output port. Okay. So how will you find here? First step is write the equations. Once you are accustomed to it, then you will be able to solve much more faster. But for now, we will go in the most disciplined manner possible. Alright. So here V11 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Okay. So now I2 if you make 0, then what will be the circuit here? You will only be left out with 20 ohms. This is 40 ohms. The voltage V2 will be present. I2 will be 0 but V2 will be present. And here V1 and I1. Okay. So now you can find out what are the two parameters you can find out. Z11 you can find out, Z21 you can find out. Z11 is V1 by I1, Z21 is V2 by I1. Now if you see the circuit, V1 is equal to 20 plus 40 into I1, right? So you write V1 is equal to 20 plus 40 into I1. So you will get Z11 is equal to V1 by I1, which is 60 ohms. Now what about the relationship between V2 and I1? So you can see that V2 is equal to 40 times the current flowing through this, which is nothing but I1. So V2 is equal to 40 I1 implies that Z21 is equal to V2 by I1, which is 40 ohms. Okay. Similarly, you can find on the other side I1 is equal to 0 if you make. Then what will be the circuit? This is going to be V2 and current I2 is flowing. V1 will be across this 40 ohms and this resistance is 30 ohms. In a similar fashion, you are going to get Z22 is equal to 30 plus 40, which is 70 ohms, and Z12 you are going to get 40 ohms. Okay. Now there are two important points that I need you to observe here. This is a T network. This is a T circuit, right? It is in the shape of a T. Now what is going to happen? Each time you see the driving point impedance Z11, this is equal to this resistance plus this resistance, and Z22, this was equal to this resistance plus this resistance. Whenever a T circuit is given, the Z parameters you can directly write. What is it you can write? Z11 will be 20 plus 40, Z22 will be 30 plus 40, and what about the transfer impedances? Simply this 40 ohms. So you can write here. The first point here is if you have an impedance like this, okay, let this impedance be ZA, ZB and ZC. Then what will be the Z11, ZA plus ZB, Z22 is equal to ZB plus ZC, and Z12 is equal to Z21, which is equal to ZB. Now next, another point that you can observe here is Z12 is equal to Z21. This is the condition for reciprocity, right? So this, when a T circuit is given which is having only impedances, then this circuit is a reciprocal network. So reciprocity condition is satisfied. Next question, obtain Y parameters for the following circuit. So this is a pi circuit. Previously we discussed a T network. This is called a pi network because it is in the shape of a pi. So let us see how to solve this. Once again you will write the equations. I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. First step that you need to do is equate Y2 is equal to 0. Here you will be able to get Y11 and Y21. So V2 is equal to 0 means you have to short circuit the output side. So what will be the circuit now. This will be 4 ohms. Here 2 ohms will be as it is. Now this 8 ohms will be short circuited because we are going to, this is V2, right? So if we short circuit V2, then 8 ohms will be short circuited. So what are you going to get here? The circuit is going to be like this. Here you have V1 and here you have I1. Here I1 by V1 will be the equivalent admittance seen through this. So what will be the admittance? The 1 by 2 reciprocal, sum of reciprocals. So 1 by 2 plus 1 by 4. So you are going to get 0.75. So this is equal to Y11. What will be the units here? It will be mho. You can write Siemens as well. Now what about Y21? Y21 is equal to I2 by V1. So where is I2? I2 is like this, right? Because V2 was here and I2 was going into the terminals. Now what will be I2 by V1? If you take this 2 ohms, this 2 ohms will be having a voltage V1 across this, right? Simply. Now what about the current? This is the positive polarity and this is the negative polarity, but I2 is entering the negative polarity, right? So you will have a negative sign. So Y21 is equal to I2 by V1, which is going to be I2, you can write in terms of the voltage as minus V1 by 2 divided by V1. So you're going to get minus 0.5 mho. Okay. So similarly you can get the other two parameters. If you equate V1 is equal to 0. So what will be the circuit? 2 ohms will be as it is. Here you will have 8 ohms and this will be short circuited. So here you are going to get voltage V2. This is I2. Current here is I1. Once again I1 is entering the negative polarity. So you are going to get Y22 is equal to, this is 8 ohms. So Y22 is 1 by 2 plus 1 by 8, sum of the admittances. This you are going to get 0.625 mho. And Y12, which you are going to get minus 0.5 mho. Okay. So here also you can see that Y21 is equal to Y12. So this is a reciprocal network. It's consisting only of the passive elements, so it will be a reciprocal network. Here also the important takeaway is, in the pi network you can easily get the Y parameters like this. So let us say this is YA, YB and YC. Then what will be Y11? This is equal to, Y11 is the driving point admittance on the input side. So this is going to YA and YB. Okay, we are talking about the admittances here. YA and YB are the admittances. So YA plus YB. So you can write here where YA, YB and YC are admittances. If it is impedance, then you have to first find the reciprocal. Okay, please remember that. And what about Y22? This is going to be equal to YB plus YC, and the transfer admittances will be Y12 is equal to Y21 is equal to YB. Okay. So when a T network is given, Z parameters are easier to find, and when the pi network is given, then the Y parameters are easier to find. Okay. So this is an important point. The next question, we have to find the Y parameters for the following circuit. Here we have a dependent source. Okay, so we will see this is a little more complicated. Let us see how to solve this. First we will mark the voltages and currents. This is V1, this is V2, and what is I1 is equal to I, and here we have I2. So this 2I we can also write as 2I1, capital I1, so that we don't have to worry about the small I anymore. Okay. So what is the first step? This is a Y parameters are short circuit parameters. So you can take V2 is equal to 0, we will first take. So when V2 is 0, then what will be the circuit? So the circuit is going to be, here you have a resistor, here you have a resistor, here you have a dependent current source. Now this is going to be short circuited. So the current I2 is flowing like this, 2I1 is flowing like this is 4 ohms, 2 ohms 8 ohms, V1 and I1. So one thing that you can see here is this is a dependent current source and a resistor in parallel. Okay, so you can apply source transformation here. You can apply. Why? Because the dependent variable is I1. I1 is not changing here. If you do source transformation, I1 is not getting affected. So you can do source transformation here. So what will be the circuit now? You will have a voltage source in series with the resistance. So the voltage source will be a dependent voltage source. Polarity will be positive here, negative here. Okay, whichever side the arrowhead is there will be the positive polarity, and the resistance will be here 4 ohm. What about the voltage source? 2I1 times into 4. So you're going to get 8I1. So this was a current controlled current source. This has now become a current controlled voltage source. We can now write the equations. You can see that I1 is the current flowing through this, I2 is the current flowing through this. So we can apply the mesh analysis. Just like in mesh analysis, we can write equations. What will be V1? This will be equal to 10 times I1. Here I2 is flowing in the same direction as I1. So you are going to get plus 2I2. This is one equation. Now the second equation, you apply KVL at mesh 2. Okay. So you're going to get what? 4 times I2 plus 8 I1 plus 2 times I1 plus I2. This is equal to 0. This is the second equation. So from here, equation 2, this will give you the relationship between I1 and I2. So let me write the final expression. I1 you are going to get minus 0.6 I2. Okay. So this if you substitute in equation 1, then what you are going to get? Then V1 is equal to 10 times, in place of I1 you can write minus 0.6 I2. So that now you will get a relationship between V1 and I2. If you want relationship between V1 and I1, then instead of I2 you can substitute in terms of I1. Okay. So this is going to be plus 2 times I2. So this is going to be minus 4I2. So what will be? Y21. This is I2 by V1 when V2 is 0. So this you are going to get minus 1 by 4 or minus 0.25 mho. Similarly, you can write V1 is equal to 10 times I1 plus 2 times I2 you can write as minus I1 by 0.6. Then Y11 will be equal to I1 by V1 when V2 is equal to 0. This you are going to get 0.15 mho.